AI is changing how we write code. Faster builds, fewer blockers, more outputs. But here's the question nobody is asking enough. As you learn AI, are you losing your ability to actually engineer systems? In this episode, we'll talk about how to use AI without losing the fundamentals that make you a real developer. I'm Oluwole, and welcome to Inside the Stack. Something important and realistic. The game has changed. And if you are starting today, you are starting in a very different world. AI tools are now part of development. They are not optional. They are not nice to have. They are part of how modern developers work. From writing code to debugging to explaining concepts. AI is now in the workflow. And this changes everything because beginners today, they can build faster way more than ever. The things that used to take weeks cannot take days. There are sometimes that it even takes just mere hours. The barrier to entry is now lower. You don't need to know everything before you start creating. And here's the part that feels almost strange at first. You can start a project, you can use tools to guide you, figure things out as you go, and you still create something meaningful. Now, this can be so powerful, but it can also be very dangerous because if you are not careful, you can build without understanding. You can copy without thinking. You can move fast, but you will stay shallow. So the shift is real, and it's a huge advantage. That is if you use it correctly. You are to use AI to accelerate your thinking, not replace your thinking. You are to use AI to unblock yourself, not to avoid the struggle. Because at the end of the day, tools can help you move faster, but your ability to think, to solve problems, to make the decisions, that's still what makes you valuable as a developer. And if you understand this early, you are already ahead of others. And let's talk about the parts that nobody really emphasizes, the risk. Because yes, you can build faster today. Yes, AI can help you generate codes. Yes, you can ship quickly to production. You can ship things quickly. But there's a downside. And if you're not careful, it will slow you down later. What is the biggest risk? The biggest risk is this: skipping the fundamentals. Things like system designs, the very basics of the programming language you are trying to code in, how requests and responses actually work, how data is stored, how data is queried and updated, how debugging, how to find and fix problems, how system flow, how everything is connected together. Now, these things are not flashy, they are not exciting, but they are the foundation. And when you skip them, you end up relying too much on generated code. You copy, you paste, you run it. It works, at least for now. But your understanding stays shallow. Now, this is where the real problem shows up. Because when things break, you're confused. You don't know where to look. You don't know what went wrong. You don't know how to fix it. And when it's time to scale, when the system gets more complex, you start struggling. Because now, you can't just generate your way out of it. You actually have to think. Now, I want you to remember this. Speed without understanding creates fragile developers. It creates developers who can build quickly but can't maintain what they build. It creates developers who can follow patterns but can't adapt when things change. So yes, use the tools, move fast, build more, but don't skip the thinking. Don't skip the fundamentals. Because in the long run, depth will always beat speed. And you see the developers who would win, the developers who win are the ones who can do both. So if fundamentals matter, what exactly are we talking about? What are the engineering foundations that we're actually discussing about, that we're talking about? Because a lot of people hear that phrase and they immediately think of tools, they think of frameworks, they think of languages, they think of libraries, but that's not it. Engineering foundations are not tools. They are how you think. They are the mental models you use to understand what's happening inside your system. Let's break it down. First, how systems communicate. When you click a button, what happens? A request leaves your front end. Am I right? It travels over the network, hits your backend, triggers logic. It talks to a database, and then a response comes back. That flow, the way the whole thing moves, and it goes back and forth, is foundational. Because once you understand that, You are no longer guessing, you are tracing. Now, second, the data flow. How does your data move from your front end to your back end, to your database and back again? Where is it transformed? Where is it validated? Where can it break? If you understand data flow, you understand your mindset. Now, third, debugging mindset. This is not just about fixing errors, but it's about thinking systematically. When something breaks, you don't panic. You ask, where could this be coming from? Is it the front end? Is it the back end? Is it the database? Is it the network? You isolate the problem. You test assumptions. You narrow it down. Now, that's a skill, and it's one of the most valuable ones you can build. And finally, writing predictable, maintainable code. Code that someone else can read. Code that behaves consistently. Code that doesn't surprise you later. Though they say the best code is code that actually documents itself. That means a code that does not need documentation. Someone can get there, read your code, and actually understand what this particular function or block of line is doing. Because it's not just about making things that work. It's about making them understandable. And when you combine all of this, you stop just being someone who just writes code and you become someone who understands system. This makes all the difference because tools will change. Yes. Frameworks will evolve. Yes. New technologies, they will come, they will go. But if your thinking is solid, you can adapt to anything, like to virtually anything. That's what foundations give you. Not just knowledge, but clarity. So now let's balance the conversation because after everything that I've said, or after everything we've said, AI is not the enemy. AI is a superpower if you use it right. When you use it right, it can accelerate your growth in ways that were never possible before. It speeds up development. Things that take hours before, searching documentation, going to Stack Overflow, asking questions, waiting for people to respond, trying different approaches. Now you can get that direction in seconds. You can unblock yourself faster. You can move with great momentum. Yeah, and AI also helps you to explore new areas. You can jump into unfamiliar territory. You can learn a new concept. You can learn a new language. You can learn a new framework. And instead of being stuck for this, you have something by the side that is guiding you, something that is helping you understand what's going on. And thirdly, it can explain concepts. It might not just give you answers. It's not only to give you answers, it's also to break down things, to simplify the ideas, to give you examples, to help things click. And honestly, this is so powerful, especially when you are learning. But here's the key. AI works best when you are thinking alongside it, not when you are blindly copying, not when you are just pasting code, but when you are asking, why does this work? What is happening here? Can I explain this by myself? Because that is how you turn AI from a shortcut into a multiplier. You should know this. AI is not replacing engineers, it's amplifying them. It makes good engineers faster, it makes curious engineers better, and it makes consistent engineers dangerous. So don't fear it, don't avoid it. Learn how to use this because in this new landscape, the advantage doesn't go to people who ignore AI, it goes to the people who know how to think and know how to use it. So now the question becomes, how do you actually use AI without becoming dependent on it? Because the goal is not just speed, the goal is depth. So here's a simple way to approach it. 5 things you need to do. First, learn the basics. That's non-negotiable. Don't skip core concepts. Don't jump straight into generating full applications without really understanding what's going on. Because AI can guide you, but it can't replace your foundation. Second, use AI to explain, not just generate. Don't just say, build this for me. Ask better questions. Explain this endpoint. Why is this query structured this way? What is happening in this function? Because when you ask for explanations, you are building understanding, not just output. Third, trace the flow. Whenever you're working on something, pause. Ask yourself, where does this request actually start? What does this backend actually do? Where is this data being stored? What does the response, or how does this response come back? What is the middleware doing? If you can follow this flow, you understand the system. Then fourth, debug without AI first. When something breaks, don't immediately run to AI. Try to solve it yourself. Read the error, trace the issue, make an attempt, embrace the struggle. Then after, use AI to compare your thinking, use AI to validate, use AI to learn. Because that struggle that you're embracing is where real growth happens. Then fifth, rebuild key parts manually. This is very important. Take up pieces of your system or of the system that you've built and rebuild them yourself. Things like authentication, CRUD operations, API calls, just to give example. What I'm saying is, don't just rely on generated code. Recreate them, understand them, break them, fix them, because here's the truth. If you can rebuild it, you understand it. And that's the goal. Not just to use AI, but to grow with it. Because when you combine speed with understanding, you don't just become just any developer, you become a dangerous one. So let's bring this home. With everything that is changing, AI evolving, tools getting faster, barriers getting lower, what does the future developer actually look like? It's not the fastest coder. It's not the person who can type the most lines of code or memorize the most syntax. And it's not the best prompter either. It's not the person who can ask AI the fanciest questions. The best developer of the future will be something or someone entirely different. It will be someone who understands systems, someone who knows how things connect, who knows how data flows, who knows how decisions affect the entire system, someone who can look beyond the code and see the architecture. And at the same time, someone who uses AI intentionally, not blindly, not dependently, but strategically. They know when to use it, they know when not to use it, they know when to think, they know when to slow down, and they know when to move fast. Because in this new world, speed is everywhere, tools are everywhere, but you see clarity is rare. And the developers who win will be the ones who combine both. Deep understanding and intelligent use of tools. That's the developer of the future. And if you start building that mindset now, you won't just keep up, you will stand out. To recap, AI is here. It's powerful and it's not going anywhere. But your goal is not just to build faster, it is to build better. Don't trade understanding for speed. Don't trade fundamentals for convenience. Because when system breaks, when things scale, when complexity increases, it is not AI that saves you. It's your foundation. If this episode helped you think more clearly about AI and engineering, share it with someone learning to code right now and subscribe to Inside the Stack, where we break down systems without the hype. I'm your host, Oluwale Majiagbe, and I'll see you in the next one. Bye.